Okay, I want to do something a little bit different today and derive this formula we have here on the board that's closely related to the Gaussian integral. I wanted to show for the integral from minus infinity to infinity of e to the minus a times x plus b squared dx. The value for this is just going to be the square root of pi over a. And what I want to use for this is the Gaussian integral, which we have over here to the right, just tells us that if we have the integral from minus infinity to infinity, e to the minus x squared, this is just square root of pi, so really similar. But what I need to do here is I need to kind of manipulate this exponent in order to get into this form where we can use the Gaussian integral. And so what I'm going to do to start to rewrite this is, what I can do is take that a and I can write it as square root of a squared, and then we'll have this other stuff, x plus b squared. But now, because everything's squared, I can kind of put these two together, write it under one parentheses all squared, and distribute in the square root of a. So what we get by doing that, we'll have square root of a times x plus b times square root of a. So now let's just take this and put it back, and I'll rewrite the integral. But now from here, what I'll do is we'll do a u substitution. If I substitute my u for all this stuff, now the integral is going to look a lot like what we have over here. So let's just write this all out. We'll have our u equal to square root of a x plus b square root of a. I'll take a derivative. Du, this is just going to be 0, so all we're left with is square root of a dx. And I think I'll just solve for dx, so we can write dx as du over square root of a. So now we'll just go ahead with this and make a substitution. So plugging infinity in, the upper bound's still infinity for this. But then plugging minus infinity here, u is going to be going to minus infinity. We have this condition over here that a is greater than 0. That's important for a few reasons, right? So of course we're going to want a positive number inside the square root here, but you'll just notice if a was negative and we have these bounds going to infinity, this thing's not going to converge, it's just going to blow up to infinity. So we need this condition over here. Now rewriting this stuff, this is going to give me e to the minus u squared, or dx is this, so I'll write it as du, but the 1 over square root of a I'll just bring up front like this. But now this thing here, this is our Gaussian integral. It doesn't matter that we have a different variable in the definite integral, so this thing is going to be just square root of pi. And so to finish it, all we need to do is multiply square root of pi by 1 over square root of a. Putting it under one radical, we get square root of pi over a. So there you have it, really quick derivation using the Gaussian integral. Thanks everyone for watching today. Have a good day.